Hello and welcome. This is going to be our lecture video for the ionic bonding worksheet. Let's go ahead and get started with problem A, potassium and iodine. So we need to start by drawing a Lewis dot structure of these two elements. So we start by writing the chemical symbol. For potassium, it's just a K. And then for every valence electron, we'll draw a dot. Potassium is in group 1, so it just gets one dot. Now iodine is in group 17, so it has 7 valence electrons, so it gets 7 dots, and notice I'm going to pair up 6 of them, and then just have one by itself. All right, so let's show this reaction happening. The more electronegative iodine will steal this electron from potassium. It's going to come right over here, and the end result will be I have a potassium ion. And now because it lost an electron, it has a positive charge. And I'll have an iodine ion. And we can give it its 8 electrons. And because it gained an extra electron, it now has a negative charge. So the cation is going to be a K plus. The anion is an I minus. The compound formula will be Ki, and the compound name would be potassium iodide. So it picks up that "ide" suffix. All right, next up, magnesium and oxygen. So start with the Lewis dot structures. Magnesium is in group 2 and will have 2 valence electrons. Oxygen is in group 16 and will have 6 valence electrons. So magnesium is going to want to lose its 2 electrons. They'll come over to the oxygen. And oxygen is willing to gain them because it only has 6. It would love to get up to 8. And so now our new ions look like this. Magnesium in a set of brackets with now a 2 plus charge, and oxygen. We'll show the 8 electrons around oxygen now with a 2 minus charge. So the cation is Mg2 plus, and the anion is O2 minus. Compound formula will be just an MgO. And we'll name this as magnesium oxide. Again, picking up that "ide" suffix because it's an ionic compound. All right, let's start trying a few more on the back, starting with aluminum phosphorus. So aluminum is an interesting one because aluminum wants to lose 3 valence electrons. Phosphorus is in group 15, so it would like to gain 3. So this is a good match, the aluminum and the phosphorus. They've got the same number to lose as to gain, so we just need 1 of each. So the aluminum has its 3 valence electrons, and the phosphorus, chemical symbol is just a P, has 1, 2, 3, 4, 5. So only 2 are paired up. The other 3 are ready to accept another pair, and then our electrons will just move to bond to these empty pairs here. And we end up with aluminum with a 3 plus charge and phosphorus with the 3 minus charge. So the cation was aluminum 3 plus, anion phosphorus 3 minus, ALP aluminum phosphide. That's the compound name there. All right, let's see, potassium and sulfur. That's kind of an interesting one because potassium can only lose 1, but sulfur can gain 2. So how this stays balanced is we start with 2 potassiums. and 1 sulfur. Sulfur looks like oxygen. It has two unpaired electrons, 6 total valence. And so the sulfur is able to steal 2 electrons, so it'll steal 1 from one potassium, 1 from another. And then our final ions will look like this. Potassium is now an ion. It gets a +1 charge because it lost an electron, and there were 2 of them. Sulfur, there's only 1 of them, but it has a 2- charge, and our charges stay balanced. The cation is the K+, the anion is the S2-. Compound formula, well, we need to represent that there's 2 potassiums, so K2S, and then we'll just call this potassium sulfide. Potassium sulfide. All right, gallium and bromine. Let's find these. Gallium's in group 13, so it's got 3 to lose, and bromine has only 1 to gain. So let's start by drawing that gallium. Gallium has 3 valence electrons, but bromine can only accept 1, so we need to draw 3 separate bromine atoms to accept the 3 separate valence electrons of gallium. Each of these does have 7 electrons around it. It can only accept 1 more to bring it up to 8. And then our ions will be gallium with the 3+, and bromine with the 1-, but there's 3 of them. All right, fill in the rest of this. Gallium 3+, bromine -, GaBr3. Call this gallium bromide. Aluminum and sulfur. That one's actually kind of interesting, because aluminum's got 3 to lose, but sulfur can only gain 2. So to make this work, with 3 to lose and sulfur with 2 to gain, what we'll do is we'll find the least common multiple of 3 and 2, which is 6, and have aluminum lose 6 electrons and sulfur gain 6 electrons. So I'll need 2 separate aluminums, each with 3 valence, and then 3 separate sulfur, each which has 6 valence, and therefore can accept 2 more. All right, and then the electrons will flow from the aluminums to the sulfurs, but each sulfur can only take 2, so the aluminums have to kind of split up their electrons to make sure they all go somewhere. And our final ions was an Al with a 3+, and we had 2 of those, and an S with a 2-, and we had 3 of those. Cation Al 3+, anion S2-. Compound formula Al2 S3 aluminum sulfide. All right, that's that for this lecture video. Have a good rest of your day.